Chapter 5.4, multiplication of monomial. Okay, let's consider this exponential form. Here is a 3 to the 4th power. What does this mean? Okay, this means the base 3 is multiplied 4 times. So 3 is multiplied 4 times. 1, 2, 3, 4, right? So the answer will be 9 times 9 is 81. Okay, how about if the base is a variable like this? X to the 6th power. Then this implies the base x is multiplied how many times? Right, 6 times. Right? So we can just write it as x is multiplied 6 times. X occurs 6 times, right? X occurs 6 times. That means, x is multiplied, 6 times. Okay, then how about this one? Here is x cubed, and I want to multiply this by x to the 4th power. Then what will be the result for this case? Okay, the first factor is x is multiplied 3 times, right? 3 times. This one. And this one is multiplied by, this multiplication by, the second factor is x to the 4th power. So this time x is multiplied 4 times. So if we separate it, so this is the first part. And this is the second part. So this is x cubed. And this is x to the 4th power. So how many x is multiplied? X is multiplied how many times? 7 times, isn't it? X to the 7th power. Can you see it? So from here we can conclude that if the base is the same, then there are 7 x's. So why don't we just add up the exponents? So there will be x to the 7th power. So instead of writing all x's as a multiplication, why don't we just add the exponent? Simple, right? So this is how we can multiply monomials. So whenever the base of exponential forms are the same, then we can add up the exponents. So when we multiply exponential form with the same base, then what do we do? Add the exponents. So again, so for the product of exponential forms with the same base, then add the exponents with the same base. So x to the nth power times x to the nth power, the bases are the same, so we can add the exponent with the same base. So when we simplify a to the 4th power times a to the 5th power, then this will be a to the 4 plus 5, so a to the 9th power. So let's simplify this expression. Because for this one, this is all product, so why don't we put numbers together? Put numbers together and v factors together and z factors together. So we can put these like factors together because this is all product. Okay, they are products, so you can change the order, using associated property. So from this, you can just multiply the numbers, then this will be negative 10. And for the v exponential forms, v is the same base, so we can add the exponents, 3 plus 2. And how about the z? The base z has exponents 5 and 6, so you can add these 2. You are adding these 2 because this is a product. Okay, this is a product. All right, then finally, this is negative 10 times v to the 5th power times z to the 11th power. So should we put the dot between this? Actually, you don't have to because this is automatically a product. So you don't have to put a dot. All right, so let's simplify this expression. Okay, this is also product. Everything's product. So we can put numbers together and the exponential form with the same base a. So a factors together. So a and a to the 5th power followed by b cubed. So b cubed is the only one. All right. Then this will be negative 20. And then a to the, this is good. A means a to the 1st power, isn't it? A to the 1st power. So we can edit 1 and 5. And then b cubed. So this will be negative 20, a to the 6th power, b cubed. Okay, so please make a note that a means a to the 1st power. So the exponent is 1. Okay, now let's check out this expression. Okay, now the base is x to the 4th power. The parenthesis is the base and 3 is the exponent. So this is an example of a power of a monomial. Okay, power of a monomial. So the base x to the 4th power is raised to the 3rd power. So this means the base x to the 4th power is multiplied how many times? 3 times, right? 3 times. So from the above, from the examples above, this means the base is x. You know, the exponential forms have the same base, x. So we can add up all exponents, right? So this is equal to x to the 4 times 3. So which is x to the 12th power. Can you see this? Alright, so this means x is added 3 times. So when you add the same number, then what do? We multiply, right? So 4 times 3 is 12. So here is a rule, exponential rule. So the monomial x to the nth power, which is the base, and this is raised to the nth power, then we can make it as x to the m times n. So multiply this m, the powers, m and n together. So that will be the result. So this is a power of another power. So 5 is a power of another power 2. So what we do is multiply the exponents. Multiply the exponent, so this will be the z to the 10th power. Make sense? All right, let's try this example on the right. Okay, the right side is the power is m and the base is a product of 2 exponential form, x to the nth power times y to the nth power. Then the result will be multiply the exponential exponents together. So x to the n times p and x to the n times p. Okay, look at this. Do you remember this one? If the base is a product like this, ab, and raised to the nth power, then you can assign the power to each factor in the base. A to the nth power times a to the nth power. So for this example, okay, the base has 2 exponential forms. One is x to the 4th power. So this one will be raised to the 6th power, and then y will be raised to the 6th power. So this will be x to the 4 times 6 is 4 times 6. You can write 4 times 6, and then y to the 6th power. So finally x to the 4 times 6 is 24 times y to the 6th power. So this formula is important. You know, the base is a product, then you can assign the exponent to each factor in the base, like this. Okay, so what I mean is this one. This is also important. Okay. All right, let's simplify this one. So the base, the parenthesis is the base, and the 4 is the power, the exponent. And the base contains 3 factors, right? 3 and n to the 5th power and p to the 2nd power. So what we're gonna do is raise each factor with the 4th power. So m to the 5th power should be raised to the 4th power, and p squared will be raised to the 4th power. Can you see it? So from this, 3 to the 4th power is 81, 9 times 9, and m to the 5 times 4, isn't it? 5 times 4. And then p to the 2 times 4th power. So that will be 81, m to the 20th power, and p to the 8th power. Alright? Or you can write the answer right away. So that is 3 to the 4th power times m to the 5 times 4 and p to the 2 times 4th power. So there will be 81 m to the 20th power times p to the 8th power. Alright, for this expression, we will do the same thing. Inside the parenthesis, which is the base, there are three factors. One is -2, and one is p to the 3rd power, and the third one is the variable r. So we will raise each factor to the 4th power. So this will be -2, it will be the base. So put parentheses around this -2, the number, and then raise to the 4th power. And then p cubed will be also raised to the 4th power, and then r will be raised to the 4th power. So that will be -2 is multiplied 4 times, so that will be 16, right? Positive 16, and p to the what? 3 times 4, and then r to the 4th power. So finally 16 p to the 12th power, r to the 4th power. Can you see it? So we can multiply the exponents directly. So, or you can do this way. So -2 is multiplied 4 times, and p to the power is 3 and 4, so multiply the powers, even the r. So r is multiplied by 4, right? 1 times 4. So that is 16 p to the 12th power, r to the 4th power.